This is a basic dynamics, kinematics type situation that we could do with basic kinematics and dynamics, but we're going to look at it in terms of energies. So we've got an 80 kilogram box sitting at rest. We've got a guy pushing on it. There's a coefficient of friction of 1.4. The box is going to go 3 meters and is going to reach a speed of 6.5 meters per second. Once again, you could do this with basic DTV, VAT, F equals MA type stuff, but we're going to do it in terms of energies. Now, when he pushes on the box, energy basically goes to two places. Some of the energy will actually go towards friction. So some of it goes to friction, of course, and of course some energy also goes to motion. And those two energies comes from the work that the guy does. So we find out how much energy goes to these two things, we can figure out how much work he must have done in the situation. So first I'm going to look at the friction part. If I want to find out the work done by friction, that would just be the force of friction times the distance the box went. Now to calculate my force of friction, that's just basic mu mg, and then I'll times that by the distance. Now if I do that, I can calculate that friction has taken up approximately 1100 joules of energy from the situation. Now I can look at the kinetic energy of the box. If I look at the kinetic energy of the box at the very end, so basically 1/2 mv squared, it starts at rest, so it doesn't have any kinetic energy at the beginning. But if I do the 1/2 mv squared for the end part at 6.5 meters per second, I can find that my box has approximately 1700 joules of kinetic energy. Now, both of these energies came from the guy. That's how much work he did. So if I put those two together, he did 2800 joules of work all together. So it doesn't really matter where that energy went to. All that really matters is it came from him. So with that idea, I can then calculate how much force he used, because force, of course, is work divided by distance. So if I take how much work he did, the 2800, and I divide it by the 3 meters that he applied it for, so I've got 2800 divided by 3, I can see that he did a force of approximately 930 newtons. And this would be an average or constant force through the entire situation.